So let's take a look at our next topic. And so here we're going to look at finding both inputs and outputs of a two-step function that models a real-world situation in function notation. Okay, so in this case, in finding inputs and outputs, so in this case, in finding the outputs, we're finding ultimately our y value. If we're finding the inputs, remember, we are trying to find our x value. So we're going to have to determine which one we're looking for based on the information given to us. Okay, so let's dive in. Let's take a look at the first example here. We have a railroad crew can lay 6 miles of track each day. They need to lay 162 miles of track in total. The length, which we'll define as L in miles, that is left to lay after D days is given by the following function. So L of D is equal to 162 minus 6D. Okay, and so we want to first determine, well, how many days will it take the crew to lay all of the track? So how many days will it take for the crew to lay all of the track? Okay. So as we take a look at this to go through and solve this, the thing to remember is how the variables are defined, and that's very important. And remember that we're told that L, okay, our output is defined in miles. And so the length L, okay, is left to lay after D days. Okay, so obviously D is your time in days. L is the amount of track that is left to lay. Okay, so with that in mind, how many days will it take, okay, for the crew to lay all the track? So we actually want to find D this time, right? We want to find D when L, the amount of track that's left to lay. Well, if it has all been laid, then that means there is none left to lay, right? So that means we want to find D when L is 0. Okay. Remember, L represents how much is left to lay after D days. Okay. So how long does it take until there are no track left to lay? All right. So that's what we're looking for here. And so with that said, let's bring down our equation. So remember, again, L of D is equal to 162 minus 6D. And once again, we're just plugging in 0 in place of L. So that means I'm left with 0 is equal to 162 minus 6D. And now we just get to solve for D. Okay. So how many days will that take? And to go through and solve it, I'll just subtract the 162 on both sides. And that'll leave us with negative 162 is equal to negative 6D. And of course, final step, divide by negative 6. And we find in this case that D, the number of days, is going to equal to 27. And of course, as always, don't forget your units. And so our result in this case would be 27 days. So again, that's saying what? That's saying that it's going to take 27 days for all of the track to be laid. Okay, so that there is ultimately no track left to lay. All right. And so along with that one, so in this scenario, notice we had to go through and solve for we had to go through and solve for the input D given the output L. So now in part B, notice we're asked to find how many miles of track does the crew have left to lay after 17 days. Okay. Well, again, the track that's left to lay, that of course is your L, and that's what we're looking to find, right? So how many miles does the crew have left to lay? So that is our L. So we're looking for this. When? Okay, after 17 days. Okay, so again, we want to find this time our L. We want to find L when D is 17. Okay, or of course, another way to look at it is we simply want to evaluate this time L at 17. And of course, just plug that in, and that would give us then 162 minus 6 times 17. And from there, just go through and simplify it. We get 162 minus 102, and that would then simplify to give us then 60 miles. Okay. So, of course, what is that saying? That's then saying that after 17 days, there is only 60 miles of track left to lay.